Hello there and welcome to another network automation video. So with network automation, we like to deal with structured data, and when using Ansible we usually have a few options, them being iOS facts, napalm facts, text FSM using network to codes, templates, NTC templates, or Cisco's libraries, the Genie libraries, which can give you structured data for lots of configuration and show commands. But other times you might find in your environment that none of those gives you the structured data that you need. And that's where custom Jinja filters come in. So in this video, I'm going to show you how you can create your own filters with filter plugins. And I'm also going to include how to use a tool that I just discovered recently called TTP, that allows you to structure data that isn't covered by one of the other libraries that I just mentioned. So again, the lab that I'm using is similar to my other videos. Today I'm only going to be concentrating on the 4 CE nodes here. So I'm going to create some custom filters and run them against these 4 nodes. So if we just start off, so when you create a custom filter, Ansible will automatically look in a directory called filter underscore plugins if you create that directory, and it expects a particular format, which is Python code. So if we just have a look at the directory, and in here I've got a couple of Python scripts. So the first one I'm going to look at is WAN underscore int, and this is a Python class that Ansible checks for. So it expects the class to be called filter module, and it expects a method or function called filters. So if we have this class and this method, then Python will automatically detect it, and it also expects the return value in this dictionary in a particular way. So with Python classes, just a couple of things. A common convention with Python classes, it's usually named with the first letter as uppercase, and the functions within a class are called methods, and the first variable passed into a method is always self. If you declare variables within the method, you have to add self dot before that variable. So if you've got a variable called myvar, you will refer to it inside the method as self.myvar. In this one, I'm not doing that. So I've created a method called getWANInt. So what I want to do in this filter plugin is I want to return the WAN interface of my routers depending on the model of the router. So I'm passing in a show var, which I will capture in a playbook, which I'll show in a second, and I call that variable here router underscore var, and then I simply have an if else conditional. And what I'm doing here is I'm checking if it's a Cisco 2911 in the router var, or a 2921, then I'm going to return the value gigabit Ethernet 0/1. Else, if it's a 4331 or 4431, I'm going to return gigabit Ethernet 0/0/1. And then I've added this other else here because in my lab, all my routers are the same. I don't have physical routers, and it's the virtual iOS, and I'm saying that my WAN interface is Ethernet 0/1. But I just want to show this as a simple example of how we can create this custom plugin. And then, as I was saying, it expects the class to return this particular format. So in this format, you can see that it's calling self.getWANInt, the method that I've declared, and then this key of the dictionary here, WAN underscore int, is what I'm going to call in my playbook. And as I said, Ansible is automatically will look for these values. So if I just have a look at my playbook now, so I've got a YAML file called wan_int. And what I do here is I'm just running this on my CE hosts. I capture a show var with iOS command and I register it to a value show_var. And then I'm going to create a new custom fact with the set fact module. I'm going to call this custom fact one underscore interface, and I'm going to pass the showvar.standard out 0 to that wan underscore int that I declared in my Python code in the filter plugins directory, and then I'm going to display the variable with the debug module, just this wan interface. So in this one, I'm going to get the same value, but when you go through this step, this wan interface is now a fact in your playbook run, so you can use that in your Jinja templates if you enclose it in double curly braces like you would any other variable. And if we just run this, so it captures the show var, runs it against the 4 routers, and then this task here is the set fact task, which is calling that Python code in my filter plugins directory, and then it's returning wan interface Ethernet 01. So if I did have different router models, I'd obviously get the different values. So then if you're configuring your wan interface in your routers, you can just refer to your wan int as double curly brace wan interface in a Jinja template. So that's that first one, quite a simple filter plugin. So the next one is a more advanced one. Recently, as I was saying, I found the TTP module that allows you to create your own templating. So I wanted to show how we can integrate that into our Python code to create a filter plugin. So in this instance, I've configured quas on each of these 4 routers with policy maps and class maps, with a parent policy map and a child policy map, which I'll show in a sec. And I noticed that in all of the libraries that I called out before, iOS Fax, TextFSM, Genie, etc., none of them are support taking your quas configuration and returning that in a structured manner. So I'm going to use the TTP module to demonstrate this. So if I just first of all just go to the documentation, so TTP template, I think we'll find it. So yeah, this is the template text parser. So this is the documentation website for this open source code that I found. So again, it's just a simple pip3 install TTP, and you should be able to, it should install for you. And if we just have a look at how we would do this. So first up, the config that I have on my routers is a parent class that just shapes average to a bandwidth and calls a child class. And the child class is simply a 3 class model, gold, silver, and a default with the bandwidth either configured with the % or with the actual values. So if we want to have a look at the parent class starting off, what we do is if I just open this one, what I do here is this is a format that TTP expects. I'm declaring this structured data to have a group name of quaz class. So it's going to return structured data, and that data is going to be called quaz class. And then I just put the config in, and anything that I want to be a variable, I enclose it in double braces like this. So the class, I'm going to have structured data for the class name, for the bandwidth of the shape average command, and then when I call the child policy, I also want that to be a variable. And then I ended with a / group, and that ends my grouping for the quaz class. So if I have a look at my filter plugins, I've also got a Python script here called quaz template. This is similar to before. It's the class is called filter module, and this filters method is declared. And this time I'm going to call for my playbook this filter plugin using quaz in uppercase. And just you can see that this is just any regular Python script, and you can import whatever libraries that is necessary. So it's very flexible. You can do pretty much anything you want. So in this instance, I've imported the TTP library and the JSON library because I want my structured data in JSON format. So I have a method called getQuaz. I'm passing into the method the policy map. So in my playbook, I'm going to run a show run pipe section policy map, say parent, and the quaz template, the file that I just showed you, which is my which is called quaz_parent.txt. And then I open that file, and I read the file and I assign it to a variable TTP_template, and then using this parser variable, I create this variable, and I parse the data using the template. So in order to do that with the TTP module, I set data to the policy map that I passed into this method, and templates to the TTP template, the file I just opened, and parse it or parse to parse the data. And then I set the variable results and I format it in JSON, and then I return the results. So if we just look at the playbook now, so it's quaz_play.yaml. So here again, I'm running it against my CE hosts. I capture the show run section policy map parent, register that to this show quaz parent variable. And then again, like I did in my previous example, I'm setting a fact called parent map, and I'm passing my registered value and calling my filter plugin quaz. And if you want to pass multiple variables into a filter plugin, the first variable is passed in here when you call the quaz filter plugin, and all subsequent variables are passed in enclosed in brackets. So in this instance, I'm passing in the quaz parent.txt file, which is in my playbook directory. So if you wanted to pass in any more variables, you just put a comma there and all your other variables. And then I display the variable that I've just created, the parent map, to see what structured data I get. So if we just run this one, quaz play. So run our command on our four routers. Then call my filter plugin that calls the TTP module, and now I've got a new variable that's a single. It's a list with a single element, which is a dictionary. So it's a parent map, And if you remember, I had the group session called Quaz class, and inside that I have my structured data, my child policy is child, my class bandwidth, and my class name, class default. So that's a simple example to get the parent class. So if we just have a look back here, the the child class now I need to do, and that's a little bit trickier. So we've a couple of variances here, and I've just put in here the um, the variables that I want to create. So the class name, and that's easy enough. I'm calling the priority as Q type. So I've got to cater for it being priority percent 30 or priority kilobit per second number. And the same with bandwidth. Oh, sorry. So I'm calling it the bandwidth value is class bandwidth, and the bandwidth mode. And then if in the class default, if you're configuring weighted red, I've just called that the red method. So if we just have a look at how that looks. So if I go back here. So this time if I just VI into it this time. So this one is a bit more detailed. So again, I'm creating a group name of Quaz class, and then the class is the class name. So then the first line is going to be either priority percent 30 or the bandwidth percent, or it could be random detect if it's in the class default. So what I've done here is for the Q type, whether it's the priority command or the bandwidth command, I'm setting that as a variable, and I'm saying that give it a default value of bandwidth if it's not declared. So again, in the class default, I don't have a priority command or a bandwidth command in this particular configuration, so I'm just giving it a default value. And then for bandwidth mode, I'm calling a macro. So I want to check if the percent keyword is used. So just to illustrate it again, I'm going to configure either priority percent, bandwidth percent, or I'm going to configure it with the kilobits per second. So I need to be able to work out if which of those are because when it's priority percent, I've got 3 individual values, but if you just call the kilobits per second, it's just 2 values. So I've created a macro. Underscore line underscore means just take this single line without that value, and I'm not 100% sure why. As I said, I've only recently found TTP, but if I don't have this in here, it was taking in the random detect in this line here and giving me output that I didn't want. So I've included that, and then I piped it into this macro check if percent, and then in the check if percent, it passes in the line, so it might be priority percent 30 or priority whatever the bandwidth is, and then I create a list, and the delimiter for my list is a space. So if it's priority percent 30, then it'll be 3 elements in my list, where the 30 is element 2, the percent is element 1, and priority is element 0. And I do a simple check. If I find percent in data, then I return element 0, which is priority, and that will become the Q type. That's the first element. That's the first variable that I'm declaring here, and class bandwidth, which is element 1. So I'm creating a variable here. Otherwise, if percent is not in the data, I return just bandwidth. So the Q mode will be, sorry, I said that wrong. Let me just start that again. The queue type is going to be priority or bandwidth. And then it's the bandwidth mode that I'm trying to set here when I call the macro. So it's bandwidth mode is when I return word list 0, that's my bandwidth mode value. And then I declare a new value, which is my class bandwidth, which is my last element in the list. And otherwise, my bandwidth mode is bandwidth, so it's going to be priority or bandwidth, and my class bandwidth is element 0. So hopefully that made sense. So if I just go back into my quas play, I just need to uncomment my child policy, and then I'll explain it. And my debug. So this is just similar to before. I'm running a show run section policy map child, registering it to show underscore quas underscore child variable, and then I call my filter plugin again, and I'm going to set it to child map, and it's called using the uppercase quas, and I'm also passing in my quas child.txt template file, and I display my variable. So let's just do that. And it's quas underscore play. So running the parent this time, then the show run policy map child, and 2 runs of my filter plugin for parent and child, and then I display the parent as before, and I display the child. So we can see now with the child map, I've got a quas class. That's the group name I declared again. So my queue type is priority. My class name is gold. My bandwidth mode is bandwidth, and my class bandwidth is in kilobits per second. So in this one, I'm configuring priority 30,000, and then in the default one, you'll see I have my red method is DSCP based. The queue type was bandwidth, which was the default method, and my bandwidth mode is remaining bandwidth, which I think I forgot to explain. So let me just go back in here. Sorry, not in there in my template. So if this is where I got the default remaining bandwidth. So what I'm saying here is I call the bandwidth mode check if %, and I set the default value of remaining bandwidth if it doesn't have it configured, and that's applicable to my default class where it gets the remaining bandwidth. It's not configured specifically. And then if we look at one with %, we should have % up here somewhere. So on site 2 router 1, the bandwidth mode is %. So in this instance, the class bandwidth is 30% of the parent shape average, class name gold, queue type priority. And then the same with the silver class, queue type is bandwidth mode is % and 25%. And that's how we get structured data using the TTP template. So I hope that was useful. I'm going to create another video where I'm going to use this structured data and I'm going to create an Excel spreadsheet where we can record it. And what we'll need to do is we'll need to have a look at where the bandwidth is configured as kilobits per second versus where it's configured as percent, and in the parent class it's configured as bits per second. So I'll do some calculations so that'll all be in an Excel report, all in the same format, and then you can run a report on your network to work out what bandwidths are assigned to each of your quas classes, which can be a challenge. Sometimes they can be misconfigured and have the wrong values and not match up with what was ordered with your MPLS provider, for example. And that concludes this video. I hope that was of help, and thank you very much.